Do you know why this $5 Nest Ally controller is better than yours? Because Google is not going to turn it off. Hi, I'm Marta and this is NotEnoughTECH, and you may wonder, what am I doing here? Oh, you probably know what I'm doing here because of the title of this video. Now, let's talk about smart heating. Technically it isn't smart heating, however it's smarter than the rest. It's probably about 30 years old as this building, and it's not been changed since. And it's just a normal Honeywell thermostat, which is linked by 4 or 3 wire terminal to the main unit. And what you can see next to it is a Sonoff Basic. And you may wonder, what is this blue thing that sticks out? And this is a temperature sensor, the HD11. Now, let's jump into a demo and then I'll show you how I did it. What I've got in here is a Node-RED interface which shows you something like Nest. It's much cheaper, because let's face it, this entire setup with Node-RED server, it's about less than $15, but it's pretty clever. So, right now the temperature in here is about 20 degrees. It's a little bit less than that, mostly because I was breathing on the sensor. And it shows you a green leaf that this is an optimal temperature. That optimum is set for me between 18 and 21 degrees. Well, 22 I think. So let's play about. So I've got here a possibility to change the heating, so let's set it to 22. And let's see what happens. Within 10 seconds a new measurement is going to be taken and the heating is off. Well, on actually, sorry. So right now I could actually hear, I don't know if you caught the click noise, but I could actually hear my heating turning on and starting to heating. Now every 10 seconds the temperature in here is going to be measured, and when it reaches the temperature, or higher the temperature, it's gonna obviously turn off. That's brilliant. How about other controls? So let's maybe try Amazon Echo. So if you have Amazon Echo nearby, mute it. Ready? Alexa, set heating to 25 degrees.
Heating is set to 25.
As you can see, the heating is set to 25 degrees and now everything is gonna run against that temperature target. I can also do manual commands. So Alexa, what's the heating temperature?
The heating temperature is 25 degrees.
So right now it shows it's 25, how about we're gonna modify it? I've set it to 14, the temperature is off, the heating's off. Alexa, what's the heating temperature?
The heating temperature is 14 degrees.
Alexa, turn heating on.
Okay.
Alexa, turn heating off.
Okay.
And it's set to away right now, and if I want to set it up again, I would have to override it with a slider or with a command. Alexa, it's cold.
I put the heating on for you.
And the heating is default set by 22 degrees with this command. So basically that's how it works. You can connect it through Node-RED, you can turn it on and off with Amazon Dash buttons, and I'm currently working on Google Home integration, because Amazon is a little bit easier to work with than Google Home for those things. However, in the next tutorial I'm probably gonna be connecting Google Assistant. Because it's Node-RED, it takes input from pretty much everything. So it's gonna be compatible with Task, it's gonna be compatible with web requests, it's gonna be compatible with if then this, if that, or whatever it's called. And, well, you can write your own scripts as well. So let's start the tutorial, shall we? So what you see in here is a Honeywell thermostat, which is connected to the main unit. And in order to disassemble it, I did it previously for you, so you don't have to watch me doing it. So you unscrew the screw on the side, then you pop the cover out using those 3 attachment points. You can use this screwdriver, and then you unscrew the main unit using 2 screws in here from the bracket itself. Make sure the electricity is off. Obviously you don't want to cause any damage or to yourself or the electrical installation. So you have 4 terminals in here, and you have in theory 4 wires. However, one is a ground wire, the earth wire, sorry, blue one is a ground, yellow is a signal, and red one is a live wire, and they are attached as so. You have 4 terminals. First terminal is a ground, second is signal, and the fourth terminal is a live wire. I'll cover that in a second when I'm gonna explain how we're gonna connect a Sonos Basic to operate this device. Now, obviously for now it's just a prototype. I know it looks slightly ugly, but it's gonna be mounted next to it and connected with a couple of cables inside, and it's gonna basically allow for the wireless operation. And later on, once I've got 3D prints, I'm gonna make a nice enclosure, and I'm gonna get rid of all that together, and I'm gonna have a nice unit with a screen. So what you have to do basically is connect both of the devices together, and you'll have a control over the temperature. Now, to have a full control via Wi-Fi, all you have to do is just set the thermostat to 0, and that way it will just be controlled by the Sonos Basic device. Now, if you want to override it, all you have to do is just set to the desired temperature, and it will override the Sonos device itself, and it will be controlled through this, which is great because if you want to revert back for whatever reason, you can just do so very easily. So you should not mess about with electricity because it's important to keep yourself safe. Now, I've took this off the wall, so that's how it's mounted. Right now it's off, and if you take the cover off, you can see that we have 4 terminals on the side, and we have a control, so this is off. I've heard a small click, so this is on right now. And now what I'm going to probe these terminals on the side to see which one are connected when that happens. So currently that was a live wire, that was a blue, and that's yellow, and I'm not 100% sure which ones are connected, so let's try it out. So live wire and the yellow terminal. Okay, that gives me a connection noise, so let's have a look if I can turn it off by adjusting the temperature. Okay, so that's what it is. The grounds keep separate, so don't wire these two. So we're gonna be setting controls between the live wire and between the this signal wire, which is a yellow here, the second terminal. So when we're gonna use the test motor device, like so, we're gonna put the wire ground on this side, and put the live wire from the one side, which is from this terminal going through test motor as a parallel, and then going out from this side and connecting to the second terminal. So I took a few liberties with carving out the hole in my Sonos Basic, and you're gonna need a sensor. In this case I'm using DHT11. You can use DHT22 if you want, it's the same library, it's supported. You need a couple of wires. For now, a couple of DuPont wires, but I'm gonna short them out later once the device is connected. So what you need is obviously open the test motor device and unscrew everything to make it easy. Take out the board. Now that test motor device should be hacked already. Well, the Sonos device should be hacked already with Thermostat software, so you should have pins and everything. There's a tutorial for that, just watch it. And just hook up the wires. I color coded them, so violet or purple for signal, red for live VCC, and black for ground. And they are connected as this. First it's signal GPO14, the second pin from that side is ground, and then VCC is the last one. Great, so right now I need to just thread that one, so I'm just gonna disconnect it from this side because they are labeled, and we're gonna thread it through the enclosure. So we've got our input from this side, output for that side, and it's important that we're gonna connect live wire from correct side to correct terminal. Make sure the connection is tight and neat, so there was no chance of wires touching each other, because you're gonna make a lot of problems if you do. And then secure the wires with the cover, so that you wouldn't be able to pull on them. Once everything's screwed in, inspect it, pull the cables a little bit, just to make sure they securely store inside, that they're locked. These wires are gonna connect like that. The live wire is gonna go here to the fourth terminal. The ground wire is gonna go to the first terminal, and the yellow wire is gonna go to the middle to the second terminal, and that's basically the connection. I'm gonna wire them together, so you will still have a control via thermostat, but if you want to control it via on-off, all you have to do is just set this position to off, and that's going to be fine because we're still going to be sending signal from here. Alright, first I'm going to start with wiring this back together. So now once this is mounted, I'm just going to screw that in and attach the on-off to it and test if it's working. So the terminal is secure right now, so what we have to do is attach the wires coming out from the on-off. And as I explained before, the on-off is going to be on one side or it can be underneath it. So yellow goes to a middle terminal, a live wire goes to the fourth terminal, and lastly the ground wire to the first terminal. Okay, the on-off is attached, so all I have to do is just add the temperature sensor, and I am ready for testing. Red to the middle, signal to the S, and ground to the ground. Now let me attach this on-off. Lastly, let's inspect the wires just to make sure there is no unwanted connections and they're fairly attached to everything. Right, we're ready for live test, so I'm just going to go and turn on the power. I'm gonna leave that rolling. Hopefully nothing's gonna interesting happen in here. You should not see anything other than light in the chance on off. And let's turn the heating on. It takes about 10 seconds to update everything. It's up to 10 seconds, it depends on the reader, because every 10 seconds I just pull the information from the sensor. You should have Sonar flashed with the latest Thermostat software. I've added the DHT to the pins, but if you're interested in how to use Thermostat software and how to flash it, I have 2 videos explaining this, so I'm not going to cover this here. Now, to set up the DHT11, all you have to do is just go to configuration, click on configure module, and then on GPO14, select DHT11 temperature sensor, save it, done. Now, the easiest way to kind of figure out what data is being, or what topic is being used to send the MQTT information to your server, just hit the console and it will tell you. So as you can see, that's the topic here, which sends the information about the temperature, and that's what I have to do in my MQTT topic. Before we're gonna jump into a Node-RED and talk about this beautiful widget, I'm just gonna add credit to Waldemar for creating it, and credit to this website because I kind of had a chance to figure out what information I have to pass over to update the widget. Let's talk about Node-RED. There's a couple of things that we have to talk about. First of all, the Nest widget isn't perfect. Basically, it requires 5 different payloads to be submitted to set the correct values. And this is not how Node-RED operates. You would rather submit a single payload with correct values to update the widget. So working with these limitations, I had to come up with a solution. And I think I'd come up with a solution. It works reasonably well and I'm happy with it. So how I do it. First of all, let's talk about the flows I've got. This is a flow for Alexa. Basically, I submit Alexa commands. You have to uncheck auto acknowledge because all the acknowledgements are being set manually, and those are acknowledgements here. So when you get the temperature, you get the temperature from the variable, you've set it in as a value, and you've submit basically a valid response. When you want to set the temperature, you check the range for minimum and maximum, and if it matches the range, you submit the value as a payload. If you're turning on or off, basically what you look, you report that the message payload true means response is valid, and then I've set the variables to on and off depending, or to specific value depending on my request. Now you've noticed I've set the flow variables. I've set them because these variables are checked every 5 seconds by this node here, and then each one of those nodes in here sends the updates to a Nest widget. So that's basically how it works. Every 5 seconds I push certain values to the Nest so it would display correct information. Now, exception is being ambient temperature, which by default is checked every 10 seconds. So I just use the topic from console, formatted it to be a JSON, then get value from the .json and set a custom topic, which is ambient temperature, average it so I wouldn't get any additional bacon or small numbers, and then push it to nest, which is basically in here 21 degrees right now. Now slider, which is just below this, I take the slider input from the slider, which is just a payload and a number, and if the slider has a topic slider, so if that's here, basically I've set the variable to whatever, and that variable is being also my payload, and that payload is passed directly to the widget, and this is the big number in here. Now for all other controls, I have a control relay. So this is very simple MQTT control node, which basically takes every 5 seconds takes the value from update and checks the variable which is updated to on or off. If it's on, obviously sends the command on. If it's off, it's off. In addition, I had to pass 2 other conditions for the Alexa. So turn off request and turn on requests with a proper payload and some additional settings. Now, I've mentioned that I have to push the updates every 5 seconds. I do that for the color away override, for away control, for the set temperature target, and every 10 seconds I do the color and leave. So color just changes the color, turns the heating on. So if the temperature, which is ambient temperature, is in the payload versus stored in variable target temperature, so if there is a difference that requires me to switch on the heating, so if the ambient temperature is lower than the target, I'm switching heating on and then switching the heating color to heating, which is orange. If it's the opposite scenario, I'm switching the heating off and I'm switching the heating color to gray, which is defined by off. Leaf, it's very similar. Basically the temperature is between 17 and 23, the leaf is on. If it's otherwise, the leaf is off. I have a special color override, so it checks if the away is off. It's activated. If the away is activated, I want the color to be off. So it's gonna get the off state for the color. Otherwise, you'll just set it to be not away to the false from the variable. Set the temperature target. There's a couple of ways I can do it. First of all, I've got Alexa commands, so this is for Alexa and this is for Alexa. If we're just querying, I don't have to change anything, so I'm just gonna because it's gonna hit this node as well. So I'm not going to do anything with the query. That's being taken care of by process Alexa responses here. Now, however, if the command is slightly different, then I want to make sure it's not on away, so cancel the away mode, then set the topic and set my variable to be whatever payload is. It's usually the value of the temperature from Alexa. Now, if that comes from the slider, then I have a topic slider, and we obviously cancel away, we set the correct topic, and then we set the variable. That's it. And obviously, once we return the message, the message payload is going to be passed over as well. And if that's from automatic every 5 second update, we just get the value stored in a variable, and we set the target temperature as a topic and pass it over for the widget to update. And lastly, just a short note on responses. So we have different responses here, and each response basically covers the Alexa correct messages, and that's being hit as well as the control relay node and set the target from the heating Alexa node. Right, I know this is a lot to take on at the same time. However, I've got this available in a written form on the website. So if you want, just head to my website and you can download all this and kind of take a look. And also there's going to be a written tutorial with correct descriptions. So that's just to give you an overview so you would know which section is what. The best thing about this setup is that it can be expanded, so I can hook it up with Amazon Dash and use it as my personal remote for heating. Try that with a Nest controller. Not gonna happen, isn't it? Anyway, this sort of basic device is about $5, and in the description you're gonna find a link, which give me a small kickback, so if you use this link, I'd appreciate it, thank you. And in the next video, we're gonna talk about 3 things. First of all, we're gonna add Google Home functionality. Second of all, we're gonna integrate Gmail Calendar, because Gmail Calendar is cool and there is no reason not to run a setup like this on a schedule. And third, and probably last one, once I've got a 3D printer, I'm gonna print out a really nice enclosure at the screen, etc. So it would look pretty and not like some sort of a hack job. If you're interested in this project, just follow me on social media. I'll be sharing the updates as I go along, and if you want to subscribe to my channel for more updates when the Google Home is enabled, calendar integrated, and other stuff. Until then, thanks so much for watching, guys, and see you next time. Bye.